There are three basic structures that things are structured as. Okay? They are atoms, ions, and molecules. How many guys have heard of all three by this point? Okay? Since we have actually talked about all three, I want to illustrate what the differences are between them. Okay? This is something that is structured as atoms. Basically, it's a bunch of atoms, and that's it. I have a bunch of atoms. Right? So if something is atomic and it's structured as atoms, it looks like this. Just a whole bunch of atoms kind of floating around. I can actually change this around here. Okay. Now they will be bonded together, if I make them a little smaller here. They will be bonded together all the way through. Right? This is actually what gold looks like. These are the atoms of gold. Okay? So, what do atoms look like? The first spot I want you to draw what atoms look like. They look like that. Just a bunch of atoms.
Are atoms really circles though?
Ish. They are circular-ish. Not perfect circles.
Sphericals?
Now, what makes an atom and not an ion?
The charge. They're not all three.
Equal numbers of protons and electrons, right? So these don't have charges because they have equal numbers of protons and electrons. They have all their electrons they're supposed to. So atoms are neutral. The positive and the negative, the protons and electrons are equal. So they haven't lost any electrons. They haven't gained any electrons. They're just normal atoms. Neutral. That would be then in the box below it, please. So in the defining features. That's a defining feature of it. Okay, now atoms are all stuck together as well. So in this case, we've got them all just kind of stuck and bonded together in one big blob. Typically, we're looking at elements. More specifically, most things that are structured this way would be metals. The example I showed you a minute ago, that was gold. If I showed you copper, it'd look exactly the same. If I showed you silver, it'd look exactly the same. You just change the color of the atom. Okay? All the metals in the periodic table would be structured this way, and they'd all pretty much look like that if you looked at them, looked at the atoms. Okay? They'd all be neutral. Now, a couple of common characteristics that they have. First off, these things are usually solid. I say usually. There's one exception. Mercury. Nope, mercury actually.
Wait, how would mercury look like that?
So mercury would just be like that, but liquidy. So they'd be still together, but kind of moving around. Okay, so mercury's the one exception, but literally every other metal on the periodic table looks like what I drew. They're all bonded together and they're all stuck together. They're all solid. They're malleable.
What?
This is a fun word. Does anybody know what malleable means?
Oh, yes.
Yeah.
Bendable, kind of?
Yeah, it's kind of like bendable
Like
or squishable.
Yeah, that.
You can think like Play-Doh or silly putty. Those are things that are really, really, really malleable. Now, I'm telling you that metal is malleable.
Very malleable.
All metals are actually like this. And you can take a copper wire and you can bend it, right? Pretty easily. You can take aluminum foil. That's a metal. It's pretty bendable, right? Every metal is bendable. Some are harder than others. It's really hard to do iron. It's really hard to bend iron. But how many guys have ever been able to take like a long, thin piece of iron and bend it? I think like a coat hanger is made out of iron mostly. You guys bend that?
Yeah.
So, malleable means bendable or squishable. Now, it is also possible to stretch it. Okay? It's squishy. If you were to hit it with something really, really hard, it's not really going to break. What it's going to do is bend or dent. Like cars are made of metal and they don't really break. They like dent and they go in, right? They bend inward. So that's what malleable means. They're also very, very conductive. They'll conduct electricity. So these are atoms. Typically things that are structured this way are going to be metals. So let's go back to the 3D here. Now let's look at ions. Okay, here's an example of something that's ionic.
Whoa, wait a minute.
That's cool.
It's not a square.
It's
not a square.
Let me turn it a little so you guys can kind of see it from different angles.
It's trippy.
Now, what's characteristic about this?
They're alternating.
They are alternating colors. You guys see that?
Yeah.
It's gray, green, gray, green, gray, green, gray, green. We have two different colors. So is this an element? No, this is going to be a compound, right? So this is going to be a compound. Since it has the word ion in it, what does that mean?
Ionic compound.
What does that mean about charges?
They're not equal. They're positive or negative.
You have positive and negative. I don't know in this case what this picture is, which one's positive or negative. Green might be positive, gray might be negative, I don't know. But this is something that is ions. This is made out of ions. Okay, alternating different ones. So, ions look like that. Now this is a 1-to-1 ratio. So I have equal amounts of the positive and negative here. One's positive 1, one's negative 1 in this picture. That's not always the case, but it's the easiest picture to draw, honestly. It's really hard to draw like a 2-to-1. Okay, the defining feature here is charges. One of these things is lost electrons and become positive. The other one has gained electrons and become negative. That's what makes it an ion. And you've got both of them, so it is alternating charges. Now all these ions are stuck together. It's a repeating pattern. You never have a positive next to a positive. You never have a negative next to a negative. But it repeats until the size of the object is over, whatever that object might be. Yes?
You said you said never a positive and a positive together.
Right.
Then how would like a 3-to-1 ratio work out?
Tricky. You're going to have some empty spaces in there too. 3-to-1s are really hard to draw.
Can you show us an image of a 3?
I don't think I have one actually.
Really?
Yeah, I can look for one, but I'm not going to spend the time right now. Ask me in a couple of days. I'll see if I can find one. I have about 100 of these, but I don't think I have a 3-to-1. I know I have a 2-to-1.
For your like thingy.
So yeah, my little 3D things. So, all right. Last but not least, these have to be compounds. Now, 99% of the time, these compounds are going to be made out of one metal and one nonmetal. Remember that metals lose electrons easily, and nonmetals like to steal electrons. They attract them. So, the nonmetal is going to be the negative one, and the metal is going to be the positive one. So it's a compound, but you're going to have both a metal and a nonmetal there. A couple of common features. These are always solid. I cannot think of a single example of something that's made of ions that is not solid.
Wait, if you put mercury and
Mercury is not ions, but mercury is one of the atoms.
mercury and germanium,
How about water?
They wouldn't form something ions.
they wouldn't.
No. That's a metal and a metal.
How about water?
Those aren't ions either. Now, typically ions are very, very hard and very, very rigid. Unlike atoms, which are malleable, if you were to hit something that's ionic, it would not bend. It would not squish. It will shatter. Okay? Rocks are ionic.
Yep.
You guys ever seen a rock bend?
Yes.
When
But it was really, 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 really hot.
Yes, rocks don't really bend, do they?
Now they fall.
No, you just kind of like put some strain on them and then suddenly they crack, right?
Yes.
That's what I'm talking about. It's not malleable, it's not squishy, it's not bendable.
mirrors, ions.
Ears?
Mirrors.
Mirrors. Mirrors are made of glass, which is hard to define, but it's
Wait.
glass is technically a molecule, but it's also one of those like little asterisks next to it. So, because it does actually have ionic similarities. So, but yeah, there are a couple of iffy, fuzzy areas here.
Always is.
Yeah, but these are hard and rigid. They also have very, very high melting points. Have you guys ever seen a rock melt?
Yes.
Yes.
Yeah.
Have you ever seen a rock melt in
Volcano.
real life?
No.
Yeah.
I can't dig that deep.
Yeah, I think most people have not actually seen rocks actually melt with their own two eyes.
Pretty cool though.
You've seen videos of them or something like that, but it doesn't happen often enough that we don't really see them that much. Okay? How are we doing so far? We good?
Yes, sir.
Ions and atoms. Okay, molecules is the tricky one here.
Oh gosh.
All right, here's a molecule.
Oh, that's like not even atom at all.
Now.
They're not even touching.
I don't want to draw that.
It's kind of there.
What do you notice? You already said it.
It's
They're not touching.
It's kind of floating around.
We've got.
I mean,
They are touching some of them. You guys see we got like little groups of
3.
3,
Yeah.
like 2 reds and a gray
That's a blue.
or a blue.
That's a blue.
Is that a blue? Yeah, it's definitely a blue. On my screen, it looks gray. So, all right, here's another molecule that you might be familiar with. This is water, by the way.
That one's blue and green.
No, it's black and gold. How dare you?
Guys, it's red and white.
I don't know. I'm colorblind.
Can you guys see the group though?
It's a candy cane.
It's a one.
Is that local?
It's a 1 red and 2 white group. Now, none of these groups are actually touching each other. Here's carbon dioxide.
Look, it's
Same thing. That's,
Here's acetone.
that's,
Wow.
wait.
How many groups do I have?
2.
3, 4.
Four.
I got 4.
I couldn't say wait.
2 white, 3 gray, 1 red.
No. 3 gray, 1 red, 6 white. Okay?
Wait, why did you say 4 then?
There are 4 groups.
Oh, 4 groups.
So there'd be 4 molecules there. Each molecule would be 2 grays, a red, and 6 whites. 3 grays, a red, and 6 whites. I think I said that wrong the first time. 3 grays, a red, and 6 whites. Okay? This would be a red with 2 whites. This would be a gray with 2 reds. And this would be a blue with 2 reds. Okay? So, molecules.
A random.
Is glass a solid?
Solid.
Because like really
It's a
young
solid.
people were taught
Solid.
it was a liquid.
No, it's a solid. All right, with molecules, guys, we have groups of atoms. They're bonded together. They're actually doing what's called sharing electrons. Chapter 9 is all about molecules. We'll discuss the process of sharing electrons in more detail when we get to Chapter 9 next week. But they do not have charges, usually. So we have electrons basically jumping from atom to atom in that little group. But nobody's actually stealing any electrons. They all still have the same number of electrons at any given moment. But the electrons are kind of constantly flowing around the group. They're sharing them. However, groups, each group does not bond to any other groups. The atoms in the group are really, really bonded very, very well to each other. And it's really hard to break them apart. But group to group, they don't bond. So the groups don't actually stick together very well. These things are usually nonmetals. This usually happens when we have things that are highly electronegative.
I think usually it has 1 S.
Does it? I'm not fixing it.
Hey,
Usually has 1 S, guys. Sorry.
Doesn't mean you have to redo like the
Yes.
those are sad.
It means I have to redo the entire slide, and I'm done doing that.
Sex.
while.
Yeah. So,
That's really dog food, bro.
usually nonmetals. Now, because these groups do not stick together, guys, these typically are gases and liquids.
This dude in my art class is
Guys.
fucking Larry.
Focus.
Smell. My doggy's good.
Why do you guys think they're typically gases and liquids?
Because they're
They're
not
not
held
bonded.
together.
They're not bonded. So these little groups, they just kind of float away. The one I actually drew here, I tried to draw carbon dioxide. Carbon dioxide, the groups don't stick together, so they just kind of float off into the room, do whatever they want. They're a gas.
They coexist.
Occasionally they do stick together slightly, but it's not because of bonding. So we'll get into that in chemistry B. But they don't really stick together that well, so there's typically gases and liquids. They're easy to separate groups, but it's really hard to separate the atoms within a group. The group stays together very, very well, but two groups don't stick together. And those are molecules. So, quick rehash. Atoms, usually made of metals. Just a bunch of atoms, all neutral. Ions, made of a metal and a nonmetal. Positive and negative charges. Molecules, groups, made of nonmetals. Little groups that the groups don't stick to other groups. Okay? These are the three basic structures of the universe.
Are there more complex structures?
There are more hybrid-y ones, which we're about to talk about next.
Yay. Joy.
Okay? So, although these are the three basic ones, there are some like in-betweens, and I want to talk today about an in-between. That's why I wanted to go and like clarify the three groups first. So the in-between I want to talk about is actually both a molecule and an ion. It's sort of both. It's sort of somewhere in between both of them. Has features of both. So, let me pull up the slide here. They're called polyatomic ions. So, polyatomic ions are molecules. That means there's several atoms that are sharing electrons or making a little group. But these molecules have a charge. That means they have an extra electron, or maybe they lost an electron. I have a few examples here.
This looks too crazy.
My doggy's dead, so I'm going to X.
Now, NO3 is a molecule. If I were to draw this as a molecule, guys, what should I draw? So let's do one nitrogen.
Stupid dog everyone's dead.
Oops.
Dog.
So I have a molecule of one nitrogen, three oxygen. Everybody with me so far?
Yeah.
Now, that's a molecule. They're all bonded together, making a group. The whole group, though, has an extra electron in it somewhere. I don't know where it is. Okay, so somewhere in there is an extra electron, giving this whole group a -1 charge. Not any individual atom in the group, the whole thing. All four atoms, all bonded together. You can treat it as one object. Okay? And it has a -1 charge. Next example, this phosphorus and oxygen. So I've got one phosphorus, 4 oxygens this time. So there's my molecule. Hold on, I want to draw a little better. Keep missing. There we go. So there's my molecule. Now this molecule has an extra 3 electrons in it somewhere. So the whole thing, I'm circling it with dotted lines to indicate I'm talking about the whole thing. The whole thing has a -3 charge. right, guys, your turn. I want you to see if you can figure out the OH molecule with a -1 charge. What do you think that'll look like? Wrong button. So I'm going to make my oxygen green again. Hydrogen blue. There's my molecule, and the whole molecule has a -1 charge. An extra electron somewhere in that molecule. Everybody with me so far?
Yes.
Okay. Next, a couple of examples. Example number 1. Na with a +1 charge. NaO3, that molecule, which has a -1 charge. Okay, so I'm going to draw an Na with a +1 charge. +1.
This is literally
I just drew anything, it's a +1. It's an ion. It's like we've kind of been drawing ions already. Okay, it's a little circle, it's got a +1, that's its charge. But for the NO3, there's an N, O, O, O. There's my molecule, and the whole molecule has a -1 charge. Okay? Everybody with me?
Yeah.
Yeah? What would the formula of this be? So I got one of each, right? Do they have equal charges?
Well,
Yeah, so that's just one of each. So just one of each ion. One ion just happens to be a molecule. Okay? So the formula, I've got one of the NAs, and then one of the NO3 molecules. Na, NO3. Questions? Okay, another example. Calcium with a +2 charge this time, and OH with a 1- charge, that molecule with a 1-. So, what color you guys want me to make calcium?
green.
Orange.
Let's do green.
Orange.
Make it a little bigger here. So calcium has a +2 charge. Okay? We'll make oxygen red.
Black.
We'll make hydrogen blue. Okay? So, oxygen,
Turquoise.
hydrogen. This molecule has a -1 charge. Are those charges equal? No. So, I'm going to have to draw another one of them. Which one?
OH -1.
The OH -1 molecule. So, I'm going to draw another one over here. Why am I putting it on the other side?
Because they don't touch.
Because they're not going to touch. So, now we've got -1, and the -1 makes -2. That equals out with the +2, right?
Yeah.
So this time I have 2 of the molecules. How do you guys think I should write the formula this time?
CaO2H2. No,
So CaOH, those are my 2 pieces.
2 OH. Like 2.
O2H2.
How's that work? Does that work?
There's 2 O's.
There's 2 O's as well, so how do I do that?
O2H2.
O2H2?
Or you can just leave it blank.
Here's how it works.
2OH.
It's not right. Can you swear it?
Here's how it works. Because we want to know what the formula of the molecule is as well as how many we have. If there's more than one of them, we put parentheses around it.
I was really thinking that.
This is the only time we're going to use parentheses with formulas.
Oh.
Okay? The only time. You only use them with these molecules that have charges, and only when you've got more than one of them. If there's only one of them, like that first example, I didn't do it, right?
Yeah.
I just wrote the formula for the molecule. But when I needed to indicate more than one of the OHs, if I just write a little 2, it doesn't really do anything for the oxygen. So I have to put parentheses around it to indicate the whole thing. Yes?
Why not O2H2?
that would lose the fact that it looks like OH. Like, I want to know what the formula of the molecule is as well as how many I have.
Okay.
So if I wrote...
If it was O2H2.
Yeah, let me just write that.
Okay.
This looks like one O2H2 molecule
Okay.
instead of two OH molecules.
Okay.
So this is a little bit more descriptive with the other way.
Okay.
Does that make sense?
Yeah.
Yeah. Okay? All right. On your whiteboards, I want you guys to try another one. I'll give you guys a minute, and then I will show you guys the answer. So, your picture should look like this. You should have one of the PO4s drawn that has a -3 charge. And then you should have 3 of the NH4s drawn, each with a -1 charge.
Wait, is it positive one? Could it?
Yeah, +1. Thank you. I screwed that up.
I'm so confused. Wait.
+1. Take 2. You should have 3 of the +1 NH4s. Okay? And only 1 of the -3 PO4s. Okay? Now your formula, 3 of the NH4 molecules, 1 of the PO4 molecules. Now I'm not going to lie, guys. These are some of the hardest ones we've done so far.
Yeah.
Tonight's homework only has 15 of them. Okay? Last night's was how many? A lot.
40.
Don't put anything away. I'm not done. I am not done. I still got one more thing to teach you. One more slide. But tonight's homework only has 15 because you do have to draw them.
Oh.
Because these are difficult to wrap your heads around, I want you to draw me a picture of how many of them you have. Okay? So, there's only 15 of them because you do have to draw them and write the formulas. The last bit is naming them.
Joy.
Wait, we're naming them now?
Naming them.
Oh, you're just.
This is gonna take us forever.
Okay. Now, naming them, thankfully, guys, is actually pretty easy. Okay? All you have to do is, just like we were naming before, name the pieces. You don't even have to change the ending. Okay, all you got to do is name what the positive one is and what the negative one is. Now, the positive ones are usually just a metal. The negative ones are usually the molecules. If you come across the molecule, you need to know the name of the molecule. I actually have this on your cheat sheet. You guys pull out your periodic tables, pull it out and look at the back right now. Pull it out and look at the back. They're up at the top. I organized them by charge. So you've got -1s, -2s, -3s, +1s, +2s, +3s. Okay? I want you guys to go ahead and find this one. C2H3O2 with a -1 charge. What's that called?
Acetate.
Acetate. The -1 tells you it's in the -1 section, by the way.
Okay.
It is called acetate. So this guy is called sodium acetate.
Okay.
Magnesium with acetate. The formula is different. I got 2 acetates with this one, but it'd be called magnesium acetate. What is the CN with a -1 charge called? Cyanide. So that's aluminum cyanide. Is naming them that hard? The hard part is you got to remember, look at this sheet. I'm not going to give you one that's not on this sheet. Okay? Real quick. Did anyone name any of these?
Nano. Nani?
Let's get the cheat sheet you can.
See if you can name one of them. Come on.
What? Sodium.
Magnesium
That is sulfate, yes.
Heather Curtis.
Magnesium sulfate. One second.